Okay, Math 140 students. This worksheet is not on the packet that I gave you in class. So you'll want to print that out, or you can just write it down and take a picture and submit it. If you are doing the book work as your submission instead, just do you try it 6 through 10 is what this compares to. So we want to do some operations with radicals. If we are multiplying radicals, then we basically just keep the radicants underneath there and multiply them out. We don't need to have like radicand. So this one's square root of 15b times square root of 15b. You can probably guess that's going to be 15b. But if we didn't know for sure, we would write the square root symbol and then we would just combine under there, not combine, but multiply 15b times 15b would give me 15b squared. And then when I simplify, that we did in parts 1 and 2, I would just be left with 15b. Okay, and remember we're just doing the principal root because we're not solving anything, we're just simplifying. So I'm going to do just a few examples just kind of quickly through. You will have some homework on this and some paper, electronic and paper. Again, the paper, I'm going to limit what you have to turn in, but you can do more for practice for studying for tests and things. And I'll post that by Thursday afternoon. So number 2 over here, we have -4 square root of 6b squared times 5 square root of 2b cubed. So we can simplify things once we multiply them out, or we can see if there's anything that's easy to do ahead of time. It's up to you how you want to attack it. Sometimes you can't really simplify as well until after you multiply it out. So we are going to go look for some obvious things that just will pull out, and then we'll see what else we can catch once we multiply any additional factors left in there. So if I look at the coefficients here, so to speak, the factors that aren't under the radical sign, we are going to have -4 times 5, so that's -20. I could also simplify out this square root of b squared and just write b. So I've got that one out. And then I have a square root of b cubed, so I could pull out the b, but left under there, kind of want to track what's left under, is my square root of 6 times 2 times, and then I still have a b left under there because 2 into 3 would be 1 factor of b, and then I still have 1 left over. So remember, if there's no exponent written there, you would want to have, it's just 1. You can maybe write that in so you don't forget. And then I'm going to simplify further. Sorry about that. Sometimes my hand accidentally hits where the zoom is on this app. So we have -20b squared. And then inside here we have 12b. So we can actually simplify further. We can take that 12b and simplify. Go ahead and see if you can do that on your own. I also want to make sure you know that if you have questions on any of these videos, you can always ask me in an email, in the comments of the assignment submission box. If you just put it in what you submit and write me a note like on your paper, I might not see it in a timely way. So emailing or writing in the comments, I have your comments sent directly to me right away. So if you have questions and you're stuck or you're not sure, or you see something wrong, just please let me know. So -20b squared is outside, and this square root of 12b, 12 could be broken down further. So I'm just going to carry everything else down, and I'm going to write down the 12 as 4 times 3, and then I still have the b all under the square root, but I can take out that square root of 4 as 2 and multiply it by the 20 outside here. So my final answer is going to be negative 40. It's a little choppy looking. Negative 40 so I get rid of that. B squared, square root of 3b is what's left under there. So that's your final answer, negative 40b squared times square root of 3b. Okay, now moving on, we have a little bit different looking problem. Number 3 is square root of 10 times quantity 4 plus square root of 2 and parenthesis. So we're going to need to distribute. So we're going to take and just follow our regular order of operations. So we would do square root of 10 times 4 and then square root of 10 times 2. So this we would end up with 4 times square root of 10 plus square root of 10 times square root of 2. I can just calculate that out as square root of 20. Now I can look to see if I can simplify anything. Square root of 10 really won't break down any further. My factors are 5 times 2. Neither of those are perfect squares, so I'm just going to leave that. Square root of 20, though, you should really get familiar with your perfect squares if you're not. I mean, this one's pretty easy to tell that that would break down to square root of 4 times 5. So we end up with 4 square root of 10 plus the square root of 4 becomes 2 times square root of 5. So I'd like you to pause the video and try number 4, which is square root of 15 times quantity square root of 5a plus square root of 2a, close parentheses. So here we have for number 4, we would distribute, we get square root of 75a plus square root of 30a. Then we can simplify that 75a to be 25 times 3a, and square root of 25 is 5. So that's what I have right here, 5 times square root of 3a. And then plus the 30a. The 30a does not break down any further. That's as simple as we can go. The same methods we're going to use for the quotient rule here. So we can multiply. First we can just make this an entire radical. So square root of 2 over square root of 10 can be put back together as square root of 2 over 10. Before we were showing how you could split them apart, but now you can put them together. So if I want to simplify that, now I can simplify what's inside that's just the radicand. So I can write it as square root of 1/5. So a couple of different roots you could go with this, but now we can't just like square this. Some people want to do that. Oh, I'll just square it and get rid of the radical sign, but it's not an equation, so there's nothing to balance off in that manner. But we don't like to have square roots in denominators, so there is something else we can do using fractions, because remember, anything over itself is 1, so we can always multiply anything by 1 and not change it. So I'm going to split this back apart. Again, you could have really just jumped to the square root of 1 over square root of 5, but just to show you why that is why I put more detail. So here, how can I get that 5 to not be a square root? I would multiply by the square root of 5. But if I do that to the denominator, I have to do that also to the numerator, or else I've changed the problem. I don't want to change the value. I just want to change, the format that it's in. So now I have this whole thing here, square root of 1 times square root of 5 on the top. So that's going to give me just square root of 5. And in the denominator, I'm going to have square root of 5 times square root of 5, which would be square root of 5 squared, which is just plain 5. And that would be my final answer, square root of 5 over 5. That's called rationalizing the denominator. So we're getting rid of the square root, which could be an irrational number, and we're making sure that it's something that's rational. Just one thing to point out to this square root of 1, I could have just got rid of the square root at that point, because square root of 1 is 1, so don't forget using that. And then the 1 over square root of 5, that is a correct answer. It's just not complete. It's not in the format that we want for this particular case in the scope of our course. But always do pay attention to the directions in calculus. You might sometimes need to leave it that way for various reasons. So go ahead and try number 6 and see how that goes. So I'm going to do out a few steps with you for this one. Hopefully you've tried it. So first thing I would do is simplify. And I just pull out that n, because the square root of n squared is n, on the top. So I have n times square root of 3 in the numerator, all divided by 3n squared times square root of 2. Now I can actually simplify using my exponent laws, and I would end up with this n over n squared is just going to give me 1 over n. So I can change that up and just have it easier to work with. And then from there, so I have square root of 3 divided by 3n square root of 2. And now, again, that is an okay, it's correct, but it's not complete in the correct format. So I do want to multiply top and bottom by the square root of 2 so I can get a rational denominator. And so I end up with square root of 6 in the numerator, and 3n times square root of 4 would be 3n times 2. So I get 6n in the denominator. So be careful here. This square root of 6, you cannot reduce out with that 6 in the denominator, because that 6 is a radicand. It's trapped up in there, and you would be doing the order of operations incorrectly if you were to do that. Now we're just going to take a quick look at what happens when we add or subtract radicals. Sometimes we can simplify things first and get some numbers to work nicely for us. The rule here is that you would add the numbers that are outside the radical sign, but the radicands themselves have to be exactly the same. It's kind of like when you were combining like terms for variables, you had to have the same base and the same exponent. So the same thing here, you have to have the same radicand and you have to have the same index. Okay, so outside here is like as if it's a 1 times square root of 2 plus 1 times square root of 5 plus 1 times square root of 2. So my like radicands are the square root of 2. Now I do have to make sure, just double check, yeah, the index is the same also. So I can add the 1, so I have 2 sets of those, or 2 factors, I should say. 2 square root of 2 plus square root of 5. And I'm just going to leave it right like that. I can't go any further. Don't try to multiply anything or that kind of stuff. It's not a fraction, so we're not going to worry about rationalizing anything. So now take a look at number 8 and try that one on your own. Negative 3 times square root of 3 minus square root of 3 plus 3 times square root of 3. Okay, now for this one, hopefully you've done number 8 and tried it. We have these like radicands that we can go ahead and we just keep the radicand the same. We don't multiply anything. We don't add them together. It's just like I have, apples there. That's an apple. So I write it down. -3, this is like a -1. So that would be -4 plus 3 is going to give me a -1 there. So I end up with negative square root of 3 as my answer. On number 9, this one, if you simplify it first, you should get something that's like. So I want you to try that. This is negative square root of 6 minus 3 times square root of 54. So if you simplify this 54, that's your hint, you'll get a perfect square in there that you can pull out and then you can add. Okay, so we should have negative square root of 6 and then minus 3 times 3, I can write square root of 6, because 54 is 9 times 6. Square root of 9 is 3. So then I get negative 6 square root of 6 minus 9 square root of 6. And so I would have negative 10 square root of 6 as my final answer. One last one to do. You can pause the video and do it on your own if you would like. We have, so this is number 10, 3 times square root of 54 minus square root of 45 minus 3 times square root of 5. So we can break that down, that 3 times square root of 54. We've already dealt with that. So we can do a 9 square root of 6 is what that becomes. 45 breaks down to 9 times 5. So again, I could pull out square root of 9 would be 3 times square root of 5, which is left under. And then minus, finally, 3 square root of 5. So I can't combine everything, but I have this, these square root of 5s, or sometimes we just say root 5 if it's square root, that I can combine. And so I would have 9 square root of 6 minus 6 square root of 5 as my final answer. So I hope that helps. Let me know if you have any questions, and have a great day.